Assalamualaikum. My name is Muhammad Amin Aikan bin Halim, matrix number AA212642 from Group 20, Section 7, JE21203, Digital Electronic, lead by TS Ahmad Al-Bakri bin Marazi. First, we intro our group members. Our group has 4 members, consists of Muhammad Haikal bin Hussein, AA210899, Muhammad Aidil Afian bin Abdul Rahim, AA210670, Muhammad Akif Faisal bin Nur Arman, AA212894, and me, Muhammad Amin Haikal bin Halim, AA212642. We start our presentation with introduction. The term of flip-flop has invented in the year 1980 by the British physicist F. W. Jordan and William Herschel, and this was named as the Herschel-Jordan trigger circuit and include the active element. The design of the flip-flop was used in the British Corellius-code breaking computer, the year 1940. The transistor version of this circuit were common in computer even after the advent of integrated circuit. So flip-flop made from logic gates are also common now. The first flip-flop circuit was known differently as multivibration or trigger circuit. Flip-flop is a circuit element where the output not only depend on the present input but also depend on the former input and outputs. There are differences of each kind of flip-flop and letters which can increase their operation. What is a flip-flop circuit? The designing of the flip-flop circuit can be done by using logic gates such as 2 NAND and NOR gate. Each flip-flop consists of 2 inputs and 2 outputs, namely set and reset, Q and Q bar. This kind of flip-flop is stated to as an SR flip-flop or SR dash. The flip-flop includes 2 states shown in the following figure. When Q equal 1 and Q bar equal 0, then it is in the set state. When Q equals 0 and Q bar equal 1, then it is in the clear state. Type of flip-flop. Flip-flop circuits are classified into 4 types based on in use, namely D flip-flop, T flip-flop, SR flip-flop, and JK flip-flop. We can see SR flip-flop. First, SR flip-flop. The SR flip-flop is built with 2 AND gates and a basic NOR flip-flop. The output of the 2 AND gates remains at 0 as long as the clock pulse is 0, irrespective of the S and R input value. When the clock pulse is 1, information from the S and R inputs permits to the basic flip-flop. When S equal R equal 1, the clock pulse occurrence routes both the outputs go to 0. When the clock pulse is detached, the state of the flip-flop is unstated. Another flip-flop is D flip-flop. The simplification of the SR flip-flop is nothing but D flip-flop which is shown in the figure. The input of the D flip-flop directly goes to the input S and its complement goes into the input R. The D input is sample to the resistance of the clock pulse. If it is 1, then the flip-flop is switched to the set state. If it is 0, the flip-flop switches to the clear state. Another flip-flop is JK flip-flop. The JK flip-flop is a simplification of the SR flip-flop. The input of the J and K flip-flop behave like the input S and R. In the same way, the output is an AND with J and CP, so the flip-flop is clear during the clock pulse only its Q bar was previous. And the last one is T flip-flop. The T flip-flop or toggle flip-flop is single input version of the JK flip-flop. The working of this flip-flop is as follows when the input of the T equals 0, such that the T will make the next stage that is similar to the current state. Okay, next one we go to the application of flip-flop. Application of the flip-flop circuit mainly involved in bounce, elimination, switch, data storage, data transfer, latch, register, counter, frequency distribution, memory and another. Some of them are discussed below. Explanation of counter. Counter is a quantum circuit. It's a group of flip-flop with a clock signal applied. Counter are of the two types, asynchronous or ripple counter or synchronous count. First, we can see how the asynchronous or ripple counter works. In asynchronous or ripple counter, external clock is applied to the clock input of flip-flop A and QA output is applied to the clock input of the next flip-flop into the flip-flop B. In synchronous counter, we can see the figure 2-bit synchronous up counter. The JA and KA input of flip-flop A are tied to the logic I, to the logic 1. So flip-flop A will work as a toggle flip-flop. Explanation of finite state machine. The finite state machine is an abstract mathematical model of a sequential logic function. It has a finite input, output, and number of states. Finite state machines are implemented in real-life circuits through the use of the flip-flop. The implement produce needs a specific order of step algorithm in order to be carried out. Example of flip-flop application. First, we can see the frequency division. As the name implies, the frequency divider circuits are used to produce the digital signal output exactly of the input frequency. We can see the example when the input signal of frequency is 100 kHz, then the frequency divider circuit will provide the output of 80 kHz. Second one, we can see the data transfer. Data transfer is the process of transferring the data from one register to another register. Data can be transferred by using flip-flop in two ways. They are serial data transfer and parallel data transfer. Third of the application flip-flop is register. There is a shift register are of the several types. There are shift left register, shift right register, shift around register, bi-direction shift register, universe shift register. Fourth application of flip-flop is counter. Counter are classified into the two types, like we can see at the top, asynchronous counter and synchronous counter. There are many types of the counter we use, such as wrist counter, BCD counter, decade counter, up-down counter, frequency counter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikam Yusin. My matrix number is AA210899 and I'm from group 20. So for the question 1 is finite state machine FSM simulation using Tinkercad. Design a more machine using 3 JK flip-flop for transition state diagram with your own design of counter sequence. Show all the steps and draw the resulting circuit. Then construct and connect the circuit using IC7473 flip-flop and other logic gates in Tinkercad. Verify your counter sequence and save your work. So for the first question, the answer is state diagram. This is our group state diagram 000, 100, 101, 010. Add the 010, 001, go to 010, and then it will continue 110. Add the 110, 110 go to 111, and 111 go to 000. We continue for the state table. At the state table, we have two things, present table and next table. At the present table, it's use the sequence or decimal 0 until 7. But at the next table, it's not use the sequence or decimal 0 until 7. It's become random. It can be 0, 3, 4, 7, 6. I give you an example. At the present table, we have 0, 0, 0. But at the next table, it become 1, 0, 0. Other than that, 0, 0, 1, it's become 0, 1, 1 at the next table. So this is our state table for my group 20. We continue the excitation state. At the excitation state, it have present state, next state, FFC, FFB, FFA. What is FFC? FFB, FFA. FFC is flip-flop C, FFB is flip-flop B, and FFA is flip-flop A. So you can see this is our answer for excitation state. I give you a few answers. At the FFC, we got 1 cross 0 cross 1 cross 0 cross 0 cross 0 cross 0 cross 0 and so on. same as like the FFB but different answer. One cross, cross 0, cross 1, 0 cross, and so on. At the FFA, 0 cross 0, 0 cross 0, 1 cross 1, and so on. This answer come from the present state. So this is our next answer for the question 1. That is K-map. So first one, this K-map is for the flip-flop C. We make it become 2. First one is for the JC and the second one is for the KC. JC input and KC input. So this is the answer for the JC input. We got the QA bar. K input, KC input, we got the QA. So other than that, other K-map is J input and K input for flip-flop B. So this is the outcome for the JB and the KB. JB is QC bar plus QA. We multiply with QA. For the K input for KB is QA. For the flip-flop A, the K-map also we divide by 2. J input and K input. So the output is for the JA equals is QC and KA equals QC, also QC. So the last answer is the circuit implementation. As you can see, this is our circuit implementation, and we also do at the Logisim.
Hi, Assalamualaikum. My name is Muhammad Aidil Afan Abdul Rahim. My metric number is AA210670. So today I want to show you our simulation circuit using Tinkercad. So this is a circuit. We use 2 JK flip-flop and another IC is OR gate. So now I want to show you the simulation. So this is a result of the simulation, which is first picture. Result for first second is 001, and for the next second is 110. The third second is 011. The fourth second is 101, and the fifth second is 010, and the sixth second is 111, and the last second is 000. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Akif Faisal bin Arman, bernombor metrik AA212894. Saya dari grup 20 akan membentangkan tentang simulation Logisim Part B. So ini adalah circuit diagram saya berdasarkan soalan yang telah diberi. Okay, so saya akan lakukan simulation berdasarkan table. Okay, first power up line nombor 1. Input dia 1111. So saya akan buat 1111. So dia punya clear adalah 1. Mana output dia kosong. Output A pun kosong, output di B kosong, output di C kosong, output di D pun kosong. So bermakna dia 0, 0, 0, 0. Line nombor 2 clear asynchronous. Okay, dia punya input 111 dan clear dia kosong. Okay, dia punya output pun kosong. Mana 0, 0, 0, 0. Seterusnya parallel load. Dia punya input di A 1, di B kosong. So okay, dia punya clear adalah 1. Okay, output di B menyala, bermakna dia akan jadi 0100. 0100. Okay, seterusnya line nombor 4 shift right. Okay, dia punya input 1111. Okay, kenalkan 1. Dia punya clear adalah 1, and dia punya clock pass 1. Dia akan output DC akan menyala, bermakna dia akan jadi 0010. 0010. Okay, seterusnya shift right untuk line nombor 5. Input dia 1111, and then dia punya clear 1, and then dia punya shift right dia yang kedua. Mana kita buat, so dia akan bertukar kepada output akan menyala di D. Okey, bermakna dia akan jadi output dia 0001 0001. Seterusnya shift right untuk nombor 6. Okey, 1111. Input dia 1111. Clear dia 1. Clock pulse yang ketiga, dia akan menyala di A. Output dia akan menyala di A, bermakna dia punya output 1000. Okey, line nombor 7, shift right nombor 7, dia punya input 1111. 1111. Clear 1, and then dia punya clock pulse 4. Dia akan menyala di B, bermakna dia akan jadi output dia 0100. Okey, seterusnya line nombor 8, shift right, input dia 1111. Clear dia 1, and then dia punya clock pulse 5. Okey, so output dia menyala di C, bermakna dia akan jadi 0010. Okey, seterusnya clear asynchronous. Okey, line yang ke-9, input dia 1111, dan dia punya clear adalah 0. So output dia 0, bermakna tiada output. Seterusnya parallel load asynchronous, line nombor 10, dia punya clear 1. Dia punya input dekat A 1001. 1001. Dia akan menyala di output B dengan C. So output dia akan jadi 0110. Okey, seterusnya adalah shift right, line nombor 11, 11. Okey, input dia 1111. 1111. Dia punya clear 1, and then dia punya clock pulse 1. 6. Okey, dia punya output yang menyala dekat C and D, bermakna dia akan jadi 0011. Okey, seterusnya line nombor 12, shift right, input dia 111, clear dia 1, and then clock pulse dia 7. Okey, input dia, output dia 1001. 1001. Okey, seterusnya line 13, 1111. Dia punya clear 1, and then dia punya clock pulse dia adalah 8. So bermakna kita buat clock pulse 8. Output dia 1100. 1100. Seterusnya line nombor 14, dia punya input 111, dia punya clear 1, dia punya clock pulse 9. So kita buat lagi sekali 9. So dia akan jadi output dia B and C, bermakna dia akan jadi 0110. 0110. Okey, yang last sekali adalah line 15, shift right, dia punya clear 1, input dia 1111. Okey, dia punya clear 10. So kita buat lagi sekali 2. Dia akan output dia akan menyala dekat C and D, bermakna dia akan jadi output dia 0011. Okey, sekian saja daripada saya. Terima kasih.